Hey guys, my name is Adam Velji, and today I will be helping you guys solve question number 8, page 378 of the Nelson Function grade 12 textbook. This question is part of the trig unit. So let's read this question together to help you guys understand it. The temperature T in degrees Celsius of the surface water in a swimming pool varies according to the following graph, where T is the number of hours since sunrise at 6 a.m. Part A asks us to find a possible equation for the temperature of the surface water as a function of time. Part B asks us to calculate the average rate of change in water temperature from sunrise to noon. Part C asks us to estimate the instantaneous rate of change in water temperature at 6 p.m. So let's further analyze this and discuss key ideas that we need to know to answer this question. So first off, T is the number of hours since sunrise at 6 a.m. So at 6 a.m., T is the number of hours, which is 0 on the graph. Question A. Find a possible equation for the temperature of the surface water as a function of time. Over here, we want to find the equation of the graph, whether it will be a sine graph, a cosine graph, positive sine graph, or a negative cosine graph. Also including amplitude, the B value, H value, the K value. Part B is asking us to determine the AROC in water temperature from sunrise to noon. So AROC is the measure of the slope of a function between 2 points on a function. It represents the average rate of change over that interval. The AROC between 2 points on a curve is the slope of a secant through the 2 points. A secant is a line that connects 2 points on a curve. So in this question, you can also use a secant to help you visually graph it to find the AROC. Part C asks us to determine the instantaneous rate of change in water temperature at 6 p.m. So the instantaneous rate of change is the measure of the slope of a function at one point on a function. This represents the slope of the function at a single x value. The AROC can be determined also by using a tangent. For all you visual learners, you can draw a tangent on the point of 6 p.m. and use 2 points and find the slope at that certain point you picked on the graph. Alright, let's move on to solve question A. Okay, so we are asked to determine the equation for this function. So let's start off with finding the amplitude. To find amplitude, we need to find max and min. So in this case, our maximum is 25, our minimum is 19. So we do max minus min divided by 2, which equals 25 minus 19 divided by 2, which equals 6 over 2, which equals 3. Next, we want to find our B value. Our B value is 2 pi divided by our period. In this case, we do 2 pi divided by our period, which is 24, or 2 pi over 15, which gives us pi over 12, or 15. Next, let's find our H value. In this case, there is no phase shift because it starts at 0. Your Y is at 0, so there is no phase shift. Lastly, let's determine our equation of axes, also known as our K value. To find K, we do max, which is 25, plus our min, which is 19, divided by 2, which gives us 22. So let's put this equation together. So this graph is a negative cos graph because it starts at a minimum value and is increasing. So this is why it's a negative cos graph. So we put our amplitude, which is negative 3, because it's a negative cos graph, multiplied by pi over 12x. There is no h value, so you only write pi over 12x. And then you add 22, which is our equation of axes. So our final equation is y equals negative 3 cos, bracket pi over 12x, bracket plus 22. Okay guys, let's move on to question B. So we need to calculate AROC, which is average rate of change. In this case, we need to determine AROC at 6. We need to determine AROC from sunrise to noon. We know that sunrise at 6, and we know that ends at 0. So h of 6 minus h of 0 all over 6 minus 0. So we need to substitute our t values, which is our 6 and our 0, into the equation. So t equals 6. We substitute the 6 into our equation over here. So we get y equals negative 3 cos multiplied by pi over 12 times 6 plus 22. This gives us negative 3 cos 90 plus 22, which equals 22. Now let's plug in t equals 0 into this equation again. T equals 0. So y equals negative 3 cos pi over 12 multiplied by 0 plus 22. This gives us negative 3 cos 0 plus 22, which equals 19. Then we know our h of 6 is 22, and we know our h of 0 is 19. So therefore, a rock equals 22 minus 19 divided by 6, which equals 3 over 6, or 0.5 degrees Celsius per hour. So therefore, the A rock in water temperature between sunrise to noon is 0.5 degrees Celsius per hour. So guys, I know it's a lot to handle, but keep calm and just do math. Okay, so lastly, we're asked to determine the instantaneous rate of change in water temperature at 6 p.m. So first, we need to calculate our IROC at t equals 6. So we do 6 plus 0.01 minus, and then we do 6 minus 0.01 to determine our h of t's. So we do 6.001 minus h of 5.999 all over 6.001 minus 5.999. Next we find our h of 6.001 and our h of 5.999. So let's start by solving h of 6.001. This is negative 3 cos times pi over 12 times 6.001 plus 22. This gives us 22.000784. Guys, remember to keep all your decimal places to make sure we get the correct answer. Now let's solve our h of 5.999, which equals negative 3 cos times pi over 12 times 5.999 plus 22. This gives us this long answer over here, 21.9992146. So now we have our h of 6.001 and our h of 5.999, and we can sub them into this equation. Therefore, IROC equals 22.0007854 minus 21.9992146 all over 0.002. This gives us 0.7854. Therefore, the instantaneous rate of change in water temperature at 6 p.m. is about 0.7854 degrees Celsius per hour. So guys, remember to keep practicing in order to get these questions correct. Now I want to talk about some application questions. So an example of a rock question that we could use in real life that demographic people use is, for example, the population of a city has continued to grow since 1950. The population thousands and the time and years since 1950 are given in the table. So we need to find the AROC by using different populations. Demographers use these populations to determine the average rate of change, determine how the population is changing in the world we live today. One more question where IROC is used is by homeowners and their appreciation for their home. For example, a family purchases a home for $125,000, and they want to know how their instantaneous rate of change has how their home has changed in value. They can solve this by using instantaneous rate of change to see how their home changes in value. And yeah, so guys, thanks a lot.